evangelist for treasure data. So how many of you out there are actually software developers? About half of you. How many of you are actually using Fluentd? None. Okay. How many of you have heard of Fluentd? Okay, so you've heard of it, but you don't use it. We're going to give you a little rundown of what it is and kind of how it works. So Fluentd is kind of a unified logging layer, if you will. Nearly every time we work with applications, with debugging, for example, when I worked for Skype in QA, basically back when it was a startup in Tallinn, Estonia, I spent a lot of time, a lot of long hours staring at debug logs and that sort of thing. And any of you who've ever worked, for example, with Android, you're very familiar, of course, with ADB Logcat. And I know I've stared at these things until I'm cross-eyed. And there's a good way to do logging and maybe a less efficient way. And I happen to think that Fluentd, and by the way, I haven't given this talk in a few months, so if I'm rusty on a few things, that's a little bit to be expected, but I am actually using Fluentd every day. So let me kind of explain. Where I'm actually coming from is I've spent a lot of time as a software engineer and also as a QA engineer, writing a lot of test automation, debugging a lot of crashes on Mozilla and Skype stack as well. And I started to make, I don't know how well you can see it, but I started to make digital art with data visualizations and fractals. And that kind of landed me into my current role as a developer evangelist, because I wanted suddenly like a data analytics pipeline, a way to consume the data that I was using for visualizations that I would be putting on, for example, RGL. I do a lot of RGL visualizations and GL shaders and that sort of thing. I have a GitHub, it's jamming too, and I'm also on Twitter as well. So if y'all want to whip out your phones and tweet about this thing, that's always a good thing to get a few more eyes on what we're doing here. Of course, I'm really grateful to the people at Cast Data for having us today. So learn a little bit about Fluentd. So what is Fluentd? Well, as I said before, it's about logging, but it's actually a little bit more than that. It's not just logging data that we can collect. It's pretty much anything, right? Anywhere we can forward data from some point in our system to some other point, right? So, for example, a web log might be an obvious thing. You can pull a web log, a log of all of your access logs, all of your 404s and so forth. You could also run, for example, if you're running like a tail command, like tailf, as some log is being written, you can actually forward that as well to another place in your system. And there's as many applications for this thing as there are actually input and output plugins for Fluentd. So we'll look at some of those. When we say that it's extensible and reliable, we're not just talking sales fluffery. In fact, we started this thing out, we started out Treasure Data actually as a bunch of open source projects, for which Fluentd was one of those. So for example, my boss, the CTO, Pezo, my other boss, Kyoto Tamura, actually started as code contributors to Fluentd. And we wanted to develop this logging layer, kind of refactor it around the software pattern of creating a common interface from where to draw the data and from where to send, from where we're sending data from. And the way that a common interface works, and we'll go a little bit more into this later, you probably already know, is that you start with a simple core. You start with a core and you build plugins around the core. So you have a common interface, and you have input plugins, and you have output plugins. And we'll go a little bit more into that as well. How we can say this thing is reliable is that buffering and failover are actually built into the tool as well, right? There's even a load balancing, there's load balancing code within Fluentd as well as some of the plugins. So in a sense, kind of redundancy is built into this as well. When we talk about data collection, we're talking about collecting logs, event logs, debug logs, and so forth. syslog-d is, of course, a notable example of this. So to elaborate, we can say that we're a data collector for a unified logging layer. We want to unify the logging story across the system where we're deployed, right? We stream our data transfer, of course, based on JSON. Fluentd is written in Ruby. There is an embedded version of Fluentd called Fluentbit. It's actually written in C, mostly, and C++. And my colleague, Eduardo Silva, actually maintains that as well. We're going to go a little bit later to fluentd.org plugins, or we can actually go in there now and look at some of the plugins available to get kind of a sense of what this thing does, right? So, how well can you see my screen? Is it even doing what it should do? Should be able to sort this thing by number of downloads. But you can see, for example, where we have output and input plugins here. If you're looking at things. So, for example, you'll see a lot of output plugins to things like well, DynamoDB, obviously, Lambda, Redshift. And the way you can tell which of these plugins are actually the best, because these are open source plugins, is to actually, you should be able to actually, there used to be a sortable version of this page where you could sort these things by number of download. I wonder if you can filter it here, actually. Yeah, I used to be able to sort this by, it looks like they've changed it. You used to be able to sort this by number of downloads to see which are the most popular. Oh, actually, we just did that. Very nice. So you can see, for example, where most people are downloading like output plugins for. Obviously, a lot of people are using us for Elasticsearch. A lot of people are using us for S3. A lot of people are also using us as kind of a flexible data host to funnel data into Amazon Redshift. In fact, we've seen quite an uptick in people who are using us, using both Fluentd and Treasure Data for that purpose. So let's go a little bit more into what just happened here. What Fluentd is, right? As we've written in Ruby, we're basically a gem-based plugin, and you can read all about us in production as well. So, as I said before, we're a data collection tool. So, back in the bad old days, and still a lot of the time now, if you have a system that consists of different things, you have a pretty much hairball of getting the data from one place to another. For example, we've got access logs in this particular system. We might have a Ruby script sending it over to BlueFlood. We might get app logs and load those into a log file, and we munch together some Python script to send it into MongoDB or maybe MySQL. Right, and then you have system logs like rsync and bash, and you need to basically patch or hack something together. Maybe your destination is Amazon S3. Anyway, the one thing that this system has in common is it has all kinds of inputs and all kinds of output destination. And you pretty much need to cobble it all together to kind of get it to work. And well, when you end up with a system that's put together like this, you're going to have basically duplicated code for error handling. Your retry mechanism, of course, is going to be very messy, because when you're transporting your log files from one place to another, you're going to have to implement some kind of a retry mechanism, right? If your code's not getting there, you need to maybe run a CRC hash or a checksum and make sure that it all got there. If it didn't, you're going to retry. If you're retrying code, for example, your retry mechanism is duplicated across a number of scripts, then you're going to have a problem. And if the guy who cobbled all this stuff, the girl who cobbled all this stuff together, quits and goes to another company, you're going to spend a whole lot of time trying to figure out what she or he did to make all this work. Again, if the retry mechanism is duplicated in your data pipeline, you're going to run into all kinds of problems, actually. So this is incredibly painful. So why not just unify it? Create one common interface, just like your normal software pattern, right? And you're able to stream all inputs in through a series of input plugins which are maintained by the community, right? To your common interface where you're doing your filtering, you're doing your buffering, you're doing your routing, and then you're routing all of this data out with output plugins to basically whatever variety of destinations you need to route it to. The point is, you no longer have to deal with something like this. So, when you have a system where there's a common interface, and you're building plugins around it, you can kind of think of it like cobbling together some Lego bricks. You're suddenly building a system that's more extensible. In the core of Fluentd, we handle the divide and conquer tasks, and I'll talk about those a little bit later. We handle most of the buffering, right? So if I need to cache my data somewhere before I can send it somewhere else, most of this is handled in the core, although the plugins also do some of the buffering as well. Most of the error handling for Fluentd is actually written into the core. And I would say, to clarify that, I would say most of the common error handling. There may be specific cases where you have a specific input or a specific output that you need to have specific errors for. Obviously, the plugins, input or output, accordingly will handle those kinds of errors. Of course, the actual message routing is handled within the core. We'll look at a configuration file later and see how that works. According to what's dictated from, first of all, the configuration, but also the input and output plugins that you're using. And also any kind of parallel processing as well, or multi-threading, is handled within the core. The plugins basically do 5 predictable things. You read data, depending on what it is, they parse the data, they buffer the data, also within the plugin as well, if needed, right? Sometimes the parsing operation requires some kind of buffering as well. They write the data, and then they format the data accordingly. Not necessarily in that order. And you can say that these are, the core is handling your common concerns, whereas your plugins are handling use case specific stuff. Meaning that common concern is that I need to buffer, I need to do error handling, obviously. Use case specific as well. I'm routing something from MongoDB to an S3 bucket, or I'm tailing a log and I'm routing it to Redshift, for example. That might be a use case specific thing. In any case, the common concern is routing something somewhere. So you can kind of look at it that way. The internal architecture of Fluentd is actually relatively straightforward. You pull the input from somewhere, you parse it, you filter it according to what basically where it's supposed to be routed to, according to your configuration or to how your input plugins are configured. You might buffer it again, you might then queue it for output, and then you might format it into the format for which your destination is going. And actually, the division between where we're talking an input plugin, a core, and an output plugin is actually kind of vague. It's not a fixed thing, of course. We could say the input in the parser stuff is input-ish, because of obviously looking at the data that's coming in from somewhere. And the buffer, the output in the format is output-ish. But actually, buffering can obviously happen internally in the core, and parsing and stuff can also happen in the core as well. So it's not a completely precise division, if you will. Here's one example of what it might look like, right? We have an input plugin, and we're setting an event. Here's a JSON event with 4 fields. We have a user, a path, a price, and a referrer. We're routing this thing through the input. Basically, we might buffer it through a plugin, through, for example, a JSON plugin. And then all the core is doing in this case is basically routing it to a specific output, right? One of the parsing operations that actually goes on is breaking down the event. And one of the things we actually pull from from our JSON event, for example, is a timestamp, because in any kind of columnar or NoSQL sort of database, a timestamp is a very critical field. Specifically, I mean time series data, of course, because everything is dependent on when an event occurred, or when an event, for example, in an application was fired, right? The same thing goes for a tag. So we know that this is an attribute of my app, and it's a specific event called bylog that we're referring to. And the actual record is the data within the event. And you see how it is there in the JSON. As we kind of see from that, like, the architecture is dealing with the input plugin, right? So we're receiving the logs, or we're actually pulling the logs from data source. So the input plugin can actually do either an active or a passive role, depending on how things are configured here. The point is that the multi-threading is handled in such a way so that this is done in a non-blocking manner. If any of you, how many of you guys have done a lot of work with JavaScript? So you know that a lot of times JavaScript operations can be blocking as well. You can try to fire an event in JavaScript, and if things don't go well, it basically blocks everything else from going on. Well, the important thing of input plugin is that it's able to signal, okay, we need some kind of multi-threading here so we can handle these multiple events. Or, whoa, this looked like one event, but it's actually firing several events. And we need to be able to do this in such a way that it's not blocking in any way. Some examples of the input plugin we see below are like our HTTP and our JSON. We can tail a file, so you run like tail f, and then you have some log that's being written to. Syslog, like syslog-d, for example, in Unix, might be another place where we're pulling stuff from. As I mentioned before, like weblog is another example. You can basically look at the input plugins and see what kind of things we handle. Output are obviously involved in writing or sending data to some kind of a destination, right? So all it's doing is basically taking the instructions from the core and saying, okay, you have this data and you need to send it or write it to that destination. That's pretty much it. But obviously that's what it looks like on the surface, but under the covers, or under the hood, if you will, it may have to do buffering, it may have to do parsing and all of those things. That's why the architecture diagram that I showed you isn't so completely distinct, right? An example of that might be, again, an out file that you're writing. Maybe you're splitting files and writing to different S3 buckets. MongoDB is another example. Incidentally, the way that our filter to Redshift works, our filter to Amazon Redshift works, is that when we're sending data out to Amazon Redshift, what we do is once we've configured the destination Redshift instance in the output plugin, we'll basically start writing multiple files to a range of S3 buckets that are geographically very closely related to the Redshift instance where we're trying to write the events to. The fact that we can do many in parallel obviously speeds the process up. And then we have another event that's fired that says, okay, create a table and with this particular schema. Because treasure data, by the way, is a schema on read system. When it's reading the data in from somewhere, it's saying, okay, it looks like we have this kind of schema, so we have a table that's got a bar chart of 10, and a big int and a small int and so forth. So it writes this table. And then it runs a series of copy commands to actually load the data from this local S3 buckets to the destination Redshift instance. And it can do that very quickly because of the basically parallel processing that's going on. Anyway, this is very much a function of our output plugins. There's another part of our architecture called the buffer plugin, right? And these are complementary to the other plugins that you saw. And their whole purpose is basically to improve memory, basically be a bit more reliable as well. So if we find, for example, and we'll go into the reliability model of Fluentd, how it is as reliable as it is in a moment here. But basically provide functionality to make this passing of data from one place more persistent and reliable, if you will. And some examples, of course, thread safety is another thing. So, ooh, we got 5 minutes. Ooh, okay. Let's just get to the demo then. So, well, I didn't realize this talk took that long. As you can see, I haven't done this in a while. So, let's just get to it, shall we? Right, very good. So, who can see my screen? Can anyone see that? Oops. Right. Can you guys see what's on my screen? No? Holy crap. I can't see it either. Wow, now you can. That's weird. Never saw that happen before. Okay, right. So let's log into a Docker. I'm going to try to do this in 5 minutes. See if I can pull it off. Like I said, I haven't done this in a while. There it goes. It's kind of down there on the bottom again. So we might just clear that again, and it disappears. Oh, nice. Very nice. Right. So let's look at our configuration file and kind of try to explain what it does. Right, so, ooh, kind of cuts off the edge there a bit. Is there some way to make it go that way more?
It's not the screen. No, it's not the screen. It's the
Okay.
resolution.
Well, you can kind of sort of see what's happening here, right? So we have the source plugin, and it says type forward here, right? And this is just saying, okay, we're going to take the data that's coming in and we're going to send it somewhere. What data are we interested in here? Well, in the case of Docker, if it's coming from a Docker container, we're going to look for standard out messages, right? And that's what's happening here. And then we're going to do all this stuff to it, right? And unfortunately, it's cut off, but you can see that it's basically saying, okay, we're going to look for standard out, and we're going to match it to this. This TV star thing is treasure data. So this is our output plugin. Here, the one thing you can see, you're probably copying it down with an API key. So we're basically going to write a table to treasure data, and we're going to route our standard out from Docker, from our Docker container to treasure data. So without further ado, let's actually do that. I have a cheat sheet here. So let's just go here. Let's do this. Right. Can you see that command? Sort of. All right. So this is going to create a Docker container. It's going to be called name test. It's going to use Fluentd as a logging driver, and it's got an option. In the case of Docker, to basically create a table named whatever the Docker container is. In this case, it's going to be test. So it's a whole lot of verbose gobbledygook to accomplish all of that. Here we go, right? So now we're in our Docker container. Echo. Hello, you lovely people. Echo. I'm not trying to flatter you or anything. Oops. I don't know what it did. Anyway, echo. So there we go. We've echoed a bunch of commands. Now, if you were paying attention, when I had the configuration file, you'll see that I had a 5-second buffer. So it's basically, it takes 5 seconds to basically store the data and upload it to treasure data, which hopefully it's done already. So let's exit that. Right. And exit again. Right. We're back. home. So let's look and see what actually happened there. So let's go to treasure data. I should by now have created a table called test. Let's see if it did. Right, so there's a table called test. Let's just see what's in it. Easiest query in the world. We could do this all from the command line as well, but I'm feeling kind of lazy. So anyway, I only have like 30 seconds probably, so heck if I would remember all that stuff. Right, okay. And here are all the events we log from the console. So that is, in a very brief nutshell, how Fluentd works to log events from a Docker container. And to that note, if I can find our presentation again. Find me. I would like to say thank you.
Any questions?
Any questions?
So on the web interface, when you're doing the query, I saw like Fresco. Is it, so where the data is actually used? Like, is it, you also mentioned Redshift. Is it in S3 or Redshift or
So,
Hive?
So treasure data has actually its own kind of storage. Treasure data has a columnar database called Plasma DB.
Okay.
Plasma consists of two things. Basically a columnar data storage. It's very similar to HBase or Cassandra, if you will. And it stores metadata in a Postgres instance as well. So it is actually the combination of those two things. Very good question. And we have, in terms of query engines, we have Presto, Pig, which as far as I know nobody uses, and Hive, of course. Hive tends to be better for like batch jobs, repeat batch jobs, but for like exploratory one-off queries, Presto tends to be a bit more efficient.
And the plugin, the Fluentd plugin, is it like in-house? Is it proprietary or open source?
Well, we have an SDK version which is of course supported, and you get us if you pay for it. But of course, Fluentd itself is free, so it's an open source. So, and I encourage you to try. Go to fluentd.org and have a look. Any more questions? So this was all so self-explanatory that we just got it. Wow, you people amaze me. What can I say? Yeah, very smart crowd. And yeah.
Writing a plugin, would you say it's a matter of weeks, months, days? I'm writing a particular plugin to connect with other type of output to send to another application.
I think it really depends on what you're connecting to. Can you actually sort of rephrase the question? Because I didn't think I got all of it.
Let's say we have another platform for visualization and we want this data to go directly to that particular platform.
Oh, okay.
So we will have to write a particular plugin. Is that a very complex effort? Is simple? What?
Then again, that depends. That depends very much. So most of our output plugins are actually developed by the community. So we have to get metrics, for example, on how long it takes. But we've already, I know for a fact, we already have like output to like Chardio. We already have output to Tableau. If we happen to be using that. So most of the common data visualization platforms, I believe, already support. Sorry. So the quick answer to your question is that we know effort because it already exists. On the other hand, I couldn't tell you how long it's taking people to produce those. I could find out. If you want to drop me a mail or something, I could look into it for you. And of course, if you're interested in a particular output, let me know that as well. I can kick that off. Any more questions? Oh yeah, we got one over here.
How do you compare Fluentd and Logstash?
That's a good question. And it's, he asked, how do we compare Fluentd to Logstash? And what I understand is that Logstash only handles a specific kinds of events. Unless I'm very much mistaken, and I could be completely wrong about this, Logstash tends to handle certain very specific analytic events, a certain class of events. Whereas Fluentd, you can, using our SDK or using Fluentd, you can pretty much write an event for anything. You saw that stupid stuff we were doing with the standard out. I don't think Logstash would be able to basically be able to consume those kind of events. I'm kind of guessing here, and that's actually a very good question. Again, I'll give you my card, and I'm going to follow up on that question for you, because that is my guess. Anyway. Right.
Yeah.
All right. So Priyanka's looking at her watch. So any more of you brilliant people who have figured this thing out in a 20-minute talk have any more questions for me? Right? Yes? No? Maybe? All right. Thank you so much.